Yes. Now, I hope my screen is visible to all of you. Yes or no? Please confirm.
Yes, sir.
Okay. So we have done this numerical. Huh? We have done the real-time problem of the process where we have analyzed how the temperature and concentration is going to change in the industry by misreading, right? So today we are going to discuss another topic of the process dynamics, that is the need to study why the process dynamics and control is important for this. और उसमें लगा देना. So you can see here what is the need. So this is the need: enhanced process safety. So for the process safety, for the safety of the process, we are using the process dynamics so that we can analyze first, and then how the safety can be made, we can implement. Okay, by satisfying the environmental constants. We already seen uh, one of the example of the sugar mill and the paper mill, where the you know the wastes are discharging directly to the river. So that also affect the environmental constants. So we have to maintain that environmental constants or satisfying the government norms given by the Bureau of Energy Efficiency and the different agency of the regulatory board of the environment. Another is the meeting ever sticker product quality. So you have to also uh, you know maintain the product quality, and this product quality is also responsibility of the process engineer. Okay, more efficient use of raw materials. So maximum utilization of the raw materials with the minimum cost. Okay, and energy, minimum energy is required, है ना? So that we can produce maximum output. Okay, maximum, we can run the you can say the process at the maximum efficiency, right? With minimum cost of energy, minimum amount of the raw materials, and like that. Okay, so increase profitability. So in the raw materials, you can also, so that the waste, whatever the waste producing, we are going to discharge into the river. This waste is also you can used as a biomass fuel and another thing, you know? So this is also the one kind of raw material you can use further. Increase profitability. Any of the process, the main motive of the process running the industry is the profit. Okay, so minimum cost and maximum output, maximum efficiency you have to maintain, right? Next, the specified production rate must be maintained. Okay, so production rate is always a big issue for the process engineers, the process industry. Okay, we have to maintain the production rate. Okay, so need to develop the process dynamics model. Why you need to develop the process dynamics? Okay, so first of all, you have to understand the process. If you are not developing the model, right, then you can't understand the process very well. Okay, second is the to train the plant engineer or the operator. Okay, if you don't know the dynamics of the system, how the dynamic of the system is going to change, then you can't be able to train your process engineer very well. Next, the develop a control strategy. If you know the process dynamics, if you know the transfer function, you know the model, you know the tangent behavior of the system, then only you can uh, well design the strategy for the control system or for the control, right? Next, the optimize the process operating condition. So also, if you know the dynamics of the system, then only what is the how the temperature is going to consume, how the pressure is going to be varying. If you know all these parameters, how the these parameters are varying with the time, then only you can optimize these parameters or the operating conditions, right? So these are the
Am I
simple.
any panda?
Who is this? Mute your mic. Mute the mic. Okay. Krishna Kumar, mute your mic, beta. Okay.
Yes, sir.
Next is the types of the system identification modeling. Most important again, when we have concluded that the dynamics is important, है ना? So you have to develop the model, right? In order to develop the model, you have to identify what are the different tools by which we can develop the model. So what are the different types of the model? So first is the theoretical modeling based on, I already said this is the based on the conservation theory. Okay, conservation theory means, or the physical law. Conservation theory of physical law means, you can say conservation of mass, है ना? Mass balance, right? Mass balance, energy balance, component balance, right? And momentum balance, right? These are the some physical law by which you can develop the theoretical model. We will see in the example also. Next, the empirical modeling. Anyone can tell me what is the empirical modeling? Any idea about the empirical modeling? Empirical modeling is emanated from data. Okay, data history important. So data history means, suppose that you have, let's say we have the, fuel rate is known for any of the manlo bike. Okay, and the efficiency, you can say, or any motor. So, and efficiency of that motor is here written, right? So you have the history of the 1 month, okay, or you can say the 24 hours. Okay, so these are the some fuel rate, and corresponding to that the efficiency is you have noted, right? So you can design your model based on this input output mapping. Input output based on this data, based on this data, you can design your input output mapping, or you can say the model. Or such this model based on the data science is known as the empirical modeling. Is known as the empirical modeling, right? And the tools generally used for in order to develop the empirical model is the regression. Is the generally regression. Okay. So the most common, ARMA model, autoregressive model, है ना? Or you can say RMAX model is one of the, uh, popular, you can say, the tools for in order to develop the empirical model. In semi-empirical model, most some of the thing are known in the as a theoretical, and some of the data is also available. So both are, theoretical and empirical modeling. Both the concept are used in order to develop the semi-empirical model, right? So this is the tools for the modeling for the process. You can see here, this is the one example. So you can see here, this is the input, this is the output. The mapping of input to output in order to process is generally known as the identification of this model, the identification of this process, the identify output from input to output, you know just we try to identify, and this identification is known as the model. Okay, so overall it is known as the model identification. Okay, so anyone is interested in order to read more about the model identification, they can read the book of the Arun Kumar Tangirala. Arun Kumar Tangirala. He is a professor of the chemical engineering in chemical engineering of at IIT Madras. IIT Madras. He has written the book System Identification. Right, system identification for the chemical engineers, and this book is also useful for the communication and instrumentation all the peoples, right? So the principle of conservation of a system, the theoretical modeling, it is the theoretical modeling, right? So in the theoretical modeling, I already told you whatever the input minus output. Simple funda is this one: input minus output, what is equals to the accumulation, right? Accumulation. So accumulation is equal to accumulation over the some time period is equal to the flow in S. You can say here, this is the, let's say, the S. The system is S. So flow in the S, right? Flow in S minus flow of S out, in minus out, you can see here, in minus out. Okay, 1 2 3 4 5, N is the input, and this is the output, M is the output. So N input minus M output plus, if the if is it any generation of the energy or something, or some mass is there inside the body? If yes, then you have to add also amount of S generated within the system. Let's say in the energy, the two types of energy, exothermic reaction and the endothermic reaction is there. Exothermic, what is, anyone can tell me what is the exothermic reaction? Exothermic and endothermic reaction, endo, please.
जिसमें एनर्जी रिलीज हो।
Energy consume or energy release. अच्छा, energy release हो. Let's say A and B are two chemicals that are in, right? So A आ रहा है, इधर से B आ रहा है, दोनों एनर्जी जब जब दोनों mix होगा, it means some energy is also released, right? Then that released energy also you have to add. Yes, the energy of A, the energy of B plus whatever the energy released. Okay, or some, if A is mass, B is mass, and some another mass is evaluate, then you have to add. Okay, so this is the amount of the S generated within the system, and similarly the consumed or the absorbed amount of S consumed within the system, if it is the endothermic, or in the case of the some absorption is there, right? In the case of mass. So whatever it means, total idea is, in minus out equals to accumulation, nothing else. In minus out equals to accumulation. This is the part of the in, this is the part of the out. Yes or no? Or consume. So this S is nothing. The quantity of S may be anything. Maybe any of the fundamental for quantities, like the mass, like the component, like the energy, like the momentum. Okay, it may be anything. मास भी हो सकता है, कंपोनेंट मास बैलेंस भी ले सकते हैं, कंपोनेंट बैलेंस भी ले सकते हैं, एनर्जी बैलेंस भी ले सकते हैं, मोमेंटम बैलेंस भी ले सकते हैं, एनीवे. ओके, so what is the mass balance? You can see here what is the mass balance. So it is very clear, in minus out is equals to accumulation, in minus out is equals to accumulation. In similar way, the conservation of component, in minus out plus rate of component I produced, right? Or is equals to rate of I accumulate. Accumulation is equals to in minus out plus something produced or something absorbed. If you can't, if you don't want to write this one also, you can ignore, right? In similar way, the energy, in minus out, है ना? In minus out plus some addition, some minus some absorption, right? So in minus out is equals to some addition minus some some surrounding energy is also there. तो कुल मिला के बात वही है कि इन माइनस आउट इज इक्वल्स टू एक्युमुलेशन, नथिंग एल्स. ओके, सो यू कैन सी हियर, अगर आपको मॉडल पता होगा, जैसे कि मैंने एग्जांपल देखा कि यहाँ पर कि नीड टू डेवलप द प्रोसेस मॉडल डायनेमिक्स, यहाँ से हम बेहतर तरीके से समझ सकते हैं कि सपोज दैट इज द ऑटो पायलट कार, and the autopilot car you have to drive, this the path is the curved, this the curved path, let's say, and the car should be going to this direction, in this direction. Okay, going into this direction, but the desired direction is like this one. Okay, so this आपको ये टोटल आपको कितनी एंगल से you have to turn. So if you want to know, so the control signal किस बेसिस पे ये काम करेगा, जब इसके आपकी पूरे सिस्टम की डायनेमिक्स होगी तब. यस और नो? If you don't know the dynamics, you can't be able to find out how much angle will be required and how this control signal will be transferred to the all those things, right? And in similar way, how this going to be controlled with the tank, the level or some temperature or some parameters. Okay, we will see from the one example, right? So okay, so in order to understand all this stuff, the transfer function, right, or the model, जो मॉडल डेवलप होकर आएगा वो जनरली you can see or you will see the that may be the algebraic equation. Generally this is the steady state equation. Steady state equation are in the form of the algebraic equation. It may be the single algebraic equation, maybe the simultaneous algebraic equation, maybe the linear algebraic equation, maybe the non-linear algebraic equation, maybe the non-linear simultaneous algebraic equation, and maybe the linear simultaneous algebraic equation. Is it clear what I'm saying? Yes or no?
Sir.
Linear
Yes, sir.
linear algebraic equation, maybe the non-linear algebraic equation, maybe the simultaneous algebraic equation, right? Algebraic equation. The model may be in the form of the ODE, ordinary differential equation, right? Maybe the first order, maybe the second order, maybe the third order. And similar way, it may be the single differential equation, maybe the simultaneous, maybe the simultaneous ODE, right? Maybe the linear, maybe the non-linear, right? Maybe the linear differential equation, maybe the non-linear differential equation, maybe the homogeneous, maybe the non-homogeneous differential equation, right? In similar way, in the partial differential equation. So ordinary differential equation and partial differential equation, the difference between these are, when you're talking about these two types of the modeling, first is the lumped type of model, and second one is the distributed model. Okay, so distributed model. So in the case of the lumped parametric model, generally the ODE is evolved. However, in the case of the distributed parametric model, you will see the partial differential equation type of the equation will come into the picture. So what is the difference between the lumped and distributed parametric model? I will let you know in some time. Okay. So I already told the different types of modeling, that is the linear, non-linear. So this equation, algebraic equation, ODE or the PD, may be the linear, may be the non-linear. Okay, maybe this equation are the static or the dynamic, maybe the equation are the lumped parametric or the distributed parametric model. So, and maybe the deterministic or the probabilistic. So first of all, tell me, uh, linear and non-linear model are very picture clear. I think there is no problem in order to identify the model is either linear or non-linear. In similar way, the static and dynamic. Static means that with varying with the, whatever the model varying with the time, that is the d by dt, is the dynamic. Yes or no? Or del by del t is nothing but the dynamic model. However, the steady state means the some algebraic equation equal to 0. Right? So this is the static equation. Uh, Lumped and distributed parameter. Anyone can tell me what is the lumped and parametric model? Then we will go further. Anyone, what any idea about this parametric model and lumped
सर जो पैरामीटर सर ओवर द होल लेंथ सर डिस्ट्रीब्यूट होते हैं आई थिंक सर वो डिस्ट्रीब्यूटेड बोलते हैं उनको
and lumped?
सर lumped means सर they are not distributed over length some are distinct parameters
Any other? Any other student?
जो पैरामीटर सारे एक साथ डिफाइन होते हैं, एक बार में डिफाइन हो जाते हैं, एक बार में डिफाइन कर लेते हैं
In the
जिनको
case of the
distributed
means concentrated.
right, very good. The idea वहीं से लिया गया है. इसको idea जो है आप जो कह रहे हैं वहीं से है. The key idea is behind for the lumped and distributed parametric model is, lumped means the model only depends on the time, right? And in the case of the distributed parametric model, you can say it is also depends on the space. Space means x, y, z, the distribution, right? As well as the time also, space and time also. Let's say there is a one rod, right? There is a one rod where some flow is going, right? Or some some temperature is going to distribute, right? सो आपने क्या किया, यहाँ से वाटर फ्लो किया, यहाँ से आपने लिया सिंपली इन माइनस आउट. सो लम्प्ड पैरामेट्रिक मॉडल में इस मैक्रोस्कोपिक इसको हम एक ऑब्जेक्ट मान लेंगे. सिंपल ये एक ये आपका कैन से द simple object here, right? But in the case of the distributed parametric model, at the t is equals to x is equals to x1. Sorry, एक x is equals to, you can say, let's say, take a minute. Let's say x is equals to here 0 and x is equals to, let's say, L. So the distribution of the temperature is varying from 0 to L. Yes or no? Yes or no? This is not uniform, right? However, in the case of the lumped parametric model, it will be the same. We are considering the temperature is same among all the parts of the rod. However, in the case of the distributed parametric model, there is the difference in the temperature, right? So this is the lumped and distributed parametric model. Okay.